All right, so today we're actually going to be talking a little bit about rocket stability. So, in order for a rocket to have a successful flight, it has to remain stable in flight. Newton's first law of motion states that every object moves in a straight line unless acted upon by a force. If a force is applied to an object in space, it will rotate around a pivot point, and this can be called the center of gravity. So what we can do here is somewhere, typically around the center, oftentimes maybe a little bit more towards the tail end, we have a symbol that stands for the center of gravity of a rocket. Now the rocket here is the object in space. So whenever a force is applied to this rocket, then the rocket is going to react to that force, causing, so if we have the force pushing to the right here, then the nose of the rocket is going to move to the right, causing the tail end to move to the left. It's pivoting around that center of gravity. The forces that a rocket experiences are caused by a lot of variables, but in this case, we'll talk about air drag on the surface areas of the rocket. And this is the friction of air resistance. So as air flows over and around down the sides of the rocket, all right, we have air resistance or friction building up along the sides of the rocket, and including actually right on the nose. So when a rocket is stabilized, this means that all of the rotating forces that would actually cause the rocket to rotate around that center of gravity, or would cause the rocket to pivot in one direction or the other, are equaled out by an opposite force. Newton's third law of motion comes into play here. It states that for every action, there is an equal and opposite reaction. The amount of surface area on a rocket is a key element in rocket stability. So as air is traveling down the length of the rocket, it is actually applying force onto the surface area of the rocket in many, many places. All right, all along the fins, along the body tubes, along even right onto the nose, wherever it might be. Wherever there is surface area, there is going to be a force being applied to that surface area from the air resistance or the friction over top of the body of the rocket. The average location of all of these forces on the rocket from the passing air, we call that the center of pressure. And go ahead and just draw the center of pressure symbol here, which is typically a circle with a dot in the center. So in order for a rocket to remain stable in flight, the center of gravity must be forward or closer to the nose of the rocket. It must be forward of the center of pressure. So if we were to bring in one additional factor here, and we say that we have some lateral winds now, which are applying a sideways force to this rocket, the average forces of the wind that's pressing on this is actually going to apply a specific force against the center of pressure. That center of pressure is then going to rotate the rocket around the center of gravity, since that is the pivot point. So in this case, a lateral wind, which is pushing from left to right, is going to cause the rocket to veer into the wind. So in this case, the interesting fact is that a rocket will always fly into the wind.